Okay, again, in the early going here, I beg your indulgence. I really want to go through these examples ploddingly, even though it involves some reading. Please forgive me, but I think it's necessary. Previous research indicates that men rate women as being more attractive when they're wearing red. And forgive the sexism or the banality of this example, but it actually does work numerically. So based on these results, these authors reason that the same phenomenon might influence the way that men react to waitresses wearing red. In their study, waitresses in 5 restaurants wore the same t-shirt in different colors. As you can see, red, blue, green, yellow, black, and white. Okay, good. And that is 6 colors, yeah. On different days during a 6-week period, except for the t-shirts, the waitresses acted normally and recorded each customer's gender and how much was left as a tip. The results showed that male customers gave bigger tips to waitresses wearing red, but that color had no effect on tipping for females. Okay, so let's limit it to males. So a researcher decided to test this result by repeating the basic study at a local restaurant. The wait staff at the restaurant routinely wear white shirts with black pants, and restaurant records indicate that the tips, that is not the way you say waitresses possessive, but anyway, indicate that the waitresses' tips for the male customers averaged 15.8% with a standard deviation of 2.4 percentage points. The distribution of tip amounts was roughly normal, and during the study, the waitresses are asked to wear red shirts, and the researcher plans to record tips for 36 misogynistic male customers. So if the mean tip for the sample is noticeably different from the baseline mean of 15.8%, so what they've done is established a 15.8% baseline with that mu equals 15.8. If the red shirt tipping rate goes above that, then the researcher can conclude that wearing the color red does appear to have some effect on tipping. On the other hand, if the sample mean still floats right around 15.8%, the same as the baseline, the researcher must conclude that the red shirt doesn't appear to have any effect. Now you'll notice, irrespective of what happens, we never speak of the word prove. We are just establishing what might be statistical significance, but never proving in the social sciences. It's a limit to what we do. So I'm establishing that baseline of 15.8%, and they went round and round to tell us this long story. They could have just told us that that was the baseline, but nonetheless, I like the texture that they create in this text. So here's an example, and again, I've taken a good number of steps to really walk through this ploddingly, and it's inefficient and slow, but I really want to grab this by the shirt to begin with. Let's state the hypothesis, or state the hypotheses. As the name implies, the process of hypothesis testing begins by stating a hypothesis about the unknown population, in this case what's going to be the tip rate for staff that wears a red shirt. Actually, we state 2 hypotheses, and frankly, I wish they would say that. Notice that both hypotheses are stated in terms of the population parameters. So here goes. And by the way, this looks wordy now. We're going to break it up into smaller parts here shortly and be adaptive about it. The first and most important of the 2 hypotheses, and you could say the first and more important, is the null hypothesis. The null hypothesis states that the treatment effect has no effect. Doing red shirts doesn't do squat. It doesn't make any difference for tipping. In general, the null hypothesis states that there's no change, no effect, no difference, no nothing happened, and thus the result is null. The null hypothesis is identified by capital H for hypothesis, and the 0 subscript says that this is the zero effect hypothesis, literally. For the study in this silly example about the red shirts, the null hypothesis states that the red shirt has no effect on tipping for the population of male customers. In symbols, this hypothesis is as follows, and here we go. Looks like I cut something off, but you'll have to forgive me here. The null hypothesis states that in the general population, there's no change, no difference, no relation, etc. The second or alternate hypothesis, also called the scientific hypothesis, alternative, etc. It's got a lot of synonyms, and sometimes you'll see it as HA. This hypothesis states that the treatment has an effect on the dependent variable. In effect, it's just the opposite. And in a second here, in the next clip, I want to get to a definition of how these things are expressed and what we're calling a two-tailed hypothesis. We'll also address one-tailed, of course.